Hey, Mr. Harridan here. We're going to go over the units for gas laws and the gas law basic premises. Premises. Okay. So pressure is P here. What can we measure pressure in? We can measure pressure in kilopascals. We can measure pressure in atmospheres. We can measure pressure in torr. We can measure pressures in millimeters of mercury or PSI. That's personally my favorite part. Pounds per square inch. Volumes. Remember, you can measure volumes in milliliters. Usually for gas laws, we're going to use liters. You can do centimeters cubed. You can technically do feet cubed if you wanted to. Temperature. There's only one possible thing for temperature. Kelvin! Kelvin! Those are the only thing you can measure temperature in is Kelvin. This is the amount of moles. So this is N stands for the number of moles. So this is moles. Yeah, they don't go away. Okay. Important things to know. You have to be able to identify your pressures, volume, temperatures, and your N's based off the units. Temperatures must be in Kelvin. Remember, to convert from Celsius to Kelvin, you have to add 273. Doesn't matter what your pressure or volume is, as long as they are the same unit. Can't use PSIs with torr, for instance. You have to convert both to PSIs. Remember that these are on the formula chart, and hopefully you know how to convert those. Then you gotta watch out for the sneaky numbers. Sneaky STP. Standard temperature and pressure. They're sneaky because the numbers are 1 atmosphere and 0 degrees C. Those are the STP numbers. They're sneaky because they'll write down STP and expect you to know the numbers. Okay. Let's look at the individual laws now here. Okay? We have Boyle's law. The independent variable for Boyle's law is volume. The dependent variable is pressure. Okay? Notice I did not mention moles and temperature. So those are my control variables. Okay? N and T. The relationship. This one is an inverse. This is the only inverse law. Okay? Which means if volume goes up, pressure goes down. You increase the volume, the pressure decreases. And this is the infamous P1V1 equals P2V2. Okay? Charles's law. Charles's law is TV because Charles in Charge was on TV. I remember watching that show when I was a kid. So my control variables are P and N. This is a direct relationship. If the volume goes up, the temperature goes up. And this is a proportion. V1 over T1 equals V2 over T2. Okay? Boyle's law is the only one that is not proportional. Guy-Lussac's law. He's French, just so you know. Guy-Lussac. He was the P and T person, which means he kept V and N constant. This is a direct relationship, meaning if the temperature goes up, the pressure goes up, or vice versa. P1 T1 equals P2 V T2. Then we got Avogadro's law. He was the one that did V and N. Remember he came up with that 6.022 times 10 to the 23rd number? Oh yeah, he did that. Yeah. Avogadro 6.022 times 10 to the 23rd. Okay. So he would study V's and N's. So he kept his P's and T's constant. And if the N went up, and V went up. And that was also a direct relationship. So his equation is also a proportion. V1 over N1 equals V2 over N2. Okay? V1 is the first volume, V2 is the second volume. V1 is the initial volume, V2 is the final volume. N1 is the initial moles, N2 is the final moles. And then, this is the one I use most of the time here actually. It's the combined gas law, where you use P's, V's, N's, and T's. So there's nothing control. And you can't do a relationship for this one either. But the big thing here is the equation. P1 V1 N1 T1 equals P2 V2 N2 T2. Now most of the time N is constant here, so we always do P1 V1 over T1 equals P2 V2 over T2. Okay? The vice president sits on top of the table. That's how I remember the equation. Vice president sits on top of the table. Okay? So on and so on. Okay. Let's go to the next page. Next page. We're going to start off with Boyle's law. Remember, Boyle's law is the only inverse law. Okay? It states that volume and pressure vary inversely when temperature and the amount of gas are constant. So remember that temperature and N, the number of moles, are constant. You know he discovered the hyperbola, right? Right. Of course we know this. Yeah. He came up with the hyperbola. Remember these curves and then you have one down there, but yeah. So remember P1 is the original pressure and P2 is the ending pressure. Any units are acceptable. It has to be the same for the volume here. So the equation is P1 V1 equals P2 V2 here. Okay? This is the equation for Boyle's law. P1 V1 P2 V2, which is an inverse relationship here. Okay? Now on the lab, you're also going to see this graph here. You're going to have to do this one, pressure versus 1 over volume. This is where you inversed the volume here, and it becomes linear. Okay? So this is pressure versus 1 over V. And then becomes linear. Big thing here, pressure and volume is an inverse law. Charles's law is next. Hey, he was a direct guy, because that means that graph is linear if you look at volume and temperature. Okay? He stated that volume and temperature directly when pressure and the amount of gas are constant. So P and N are constant here. Came up with the equation V1 over T1 equals V2 over T2. Think of a hot air balloon. They blow hot air into the balloon and the balloon gets bigger, right? So the temperature of the air is increasing, so the volume of the balloon is increasing. Remember, you must use Kelvin. We cannot use Celsius. These laws, proportion laws, do not work with negative temperatures. Celsius has negative temperatures. We can't use those. Likewise, Celsius has 0 degrees Celsius. You can't put 0 degrees at the bottom of a fraction. That is undefined, so you cannot do that. Okay? And the graph is on here. Next page. Guy-Lussac's law. He was another guy that was direct. Okay? Which means our graph, again, is linear. Okay? He stated that pressure and temperature vary directly when volume and the amount of gas are constant here. So here we have volume and N are constant. Equation for this one is P1 T1 equals P2 T2. Wow, you picked the names of the burette and pipette. Good job, dude. Remember, we have to use Kelvin. Because again, we're using temperatures and they have to be in Kelvin. Okay? Avogadro's law states that the volume and amount of gas are directly proportional when pressure and temperature are constant. So his law is, why didn't we write this here somewhere? His law is V1 over N1 equals V2 over N2. Okay? And what was constant for Avogadro's law? Remember, he's a direct guy. What was constant was constant P and T. Okay. Hey, he also helped us come up with a great conversion of 22.4 liters per mole. Remember 22.4 liters? One bowl equals 22.4 liters of ideal gas at STP. Yeah, I might have time to derive that for you. Okay, here we go. Let's look at some examples to think about here. Hey, Charles did a lot of work on hot air balloons. Hot air balloons work by heating up the air in the balloon, and then the balloon rises. Hey, I just said that before in the video. Explain why this works using gas laws. Think back to why one liquid floats on top of the other here. Okay. So if you heat up the air, the volume increases. Molecules spread out because they're moving faster because the temperature is increasing. The density becomes less because we know hot air rises. Do you know why hot air rises? Because it's less dense. So then it floats higher. Remember, this is V1 over T1 equals V2 over T2. Okay? If you sit on a closed bag of potato chips, why would you sit on potato chips? They're so yummy. Nobody would sit on them. It would pop. Why? Whose gas law does this demonstrate? That's a great question. So if you sit on the bag, the volume decreases, which means the pressure increases. The temperature's not changing when you're sitting on a bag. So this must be P1 V1 equals P2 V2. That must be Boyle. Even though an airplane is pressurized, it's still at a lower pressure than sea level. Take a bag of potato chips on a plane. Oh, that's a good idea. Potato chips on a plane. Yummy. It will expand. Whose gas law does this demonstrate? Okay. So the pressure here on the outside of the bag decreases. Molecules expand more. Meaning volume increases. So this is also Boyle's law because P1 V1 equals P2 V2. Here again, temperature's not changing here, so it has to be Boyle's law. Okay? Tires in a vehicle need a certain level of pressure to run optimally. Why are people encouraged to check their tire pressures in both the summer and the winter? Whose gas law does it demonstrate? Oh boy, here. Okay, you know, in the summer, there's an increase in temperature. Yeah, it's warmer in the summer. If there is an increase in the temperature, the pressure of the tires increase. And it's vice versa in the winter. Okay? Which means we're looking at P1 over T1 equals T2 over T2. And you can't see anything I'm writing. That's awesome, Mr. Harridan. Stay on the screen. Stay on the screen. Summer increase of temperature, pressure, the tires have increased, vice versa for winter. P1 T1 equals P2 over T2. This is Guy-Lussac's law. If the gas of a doubles from 100 degrees to 200 degrees. Does that mean the volume also has doubled and if the pressure is constant? Explain. Most people would say, yes, okay, the temperature doubled. But the problem is, the temperature ain't in Kelvin. So the answer is no. Temperature must double in Kelvin. Because 100 degrees Celsius in Kelvin is 373. Which 200 degrees is 473, which is not a double. Right? Because we're talking about 373 Kelvin to 473 Kelvin. That's not a double. That's not a double. Okay? You have to do the gas laws in Kelvin. Okay. You guys are champions. The legend is out. Love the bells.